So I found the first derivative, which was 4x cubed minus 12x squared. Second derivative is going to be 12x squared minus 24x.
Perfect. So I left some space. So the first part of the first part of finding a relative max or min is going to be the same whether you're using the first or second derivative test. So we'll take our derivative and then let's find our critical points.
Okay. So then critical points would be, I guess you can factor out 4x squared. So then it's going to be x minus 3. So then the critical points are going to be 0 and 3. And then it's never going to be undefined.
Perfect.
And then do you draw like the line thing?
So that'll be the first derivative test. Yes, doing a sign chart, it will be the first derivative test. So instead, the second derivative test, so you took the second derivative flawlessly, we're going to find the second derivative at those two critical points.
Okay.
Oh my God.
So then that's going to be 0.
Yes.
And then at 3, it's going to be, so then it's 36. F of 3 equals 36.
Yes.
Okay, so and then
what that tells us is, so since this is positive, that's telling us that F is concave up at 3. So if I'm concave up and I have a horizontal tangent, that means that at 3 would be a relative min.
Oh, okay, that makes sense.
Yeah, because f prime of 3 is 0, so it's a critical point, and then the second derivative is positive, so that'd be concave, or so it'd be a relative min. If we were concave down, then it would be a relative max. Now, the second derivative test is bad for when you get 0, because it's inconclusive.
Because it's inconclusive, yeah.
Yes, so we'll have to go back and actually do the first derivative test with it.
So then for that one, it's going to be negative for what? Wait, hold on. Yeah, negative for less than 0. And then positive, wait, no, actually I didn't even check. And then also negative until 3.
Good.
And then positive after 3. So then it is going to be, there's going to be no like relative min or max around 0.
Good.
So I'm kind of wondering when do you use the second derivative test?
Oh, great question. So you only have to use it if you run into a case. Here, I'm going to copy this. Since they're doing their derivatives. Let me try to make this smaller if possible. So if you have like an implicit problem where you have x and y in your derivative, so you couldn't do a sign chart because you're like, okay, if I I know one's my critical value, but like, do I plug in 0 what? So then you have to use a second derivative test.